Hey, welcome back. Today we're going to be talking about some basic linear regression. Not only are we just going to fit the model, we're also going to dig into the matrix algebra and take a look at what's happening on a theoretical level. Without further ado, let's get started. So let me make a text box. And I'm going to say simple linear regression. The first thing is that I want to be able to create the data so that I know theoretically what is the correct model. And then we're going to take it from there. So import numpy as np, and we're going to define x as 2 times np random rand. Let's make it 100. So what this will do is it's going to generate a bunch of numbers, precisely 100 of them, and then this is one dimensional, and we're going to assign that to x. Now we're going to build some sort of model y. Say this is 2 plus 3 times x plus some sort of noise. Okay, so we're going to call this noise. And before we move on, I want to assign all of these things as parameters. For example, we have theta 1, theta 2, and noise, and we're going to define all of them. Theta 1, let's put it here. 3, that's theta 2, so let's put it here. And then we're just going to make up some random numbers. 2, that could be 3. Noise, I'm going to define as actual noise. So random, normal, 100 by 1. Boom. So y is essentially a vector with the same dimension as x. Specifically, we're talking about this sort of relationship with x. Now we can build some model. Let me make a markdown block, and let me write it like this. So math form of linear model, that could be, so we're talking about y, and that's going to be defined as this x, which is a data frame, times, I'm going to use c dot, a parameter vector plus your epsilon, which is your noise. So it looks something like that, except that these terms are matrices. So now what we want to do is we want to solve for your b. Essentially, this is essentially your b hat. So hat b. So what this is an inverse matrix of x with the dot product of b. So essentially it looks like the following. This is going to be x transpose x to the power of -1. So we're inverse the matrix. And then times xt, give it a y. Boom. I forgot the $sign. Boom. Okay, so now we're going to code this in terms of numpy knowledge. We're having this matrix X, and we're treating this Y as a one-dimensional matrix, it's like a vector, and we're trying to find this b hat. So the first thing is I'm going to introduce a constant that help me model this data. So it's like there's a hidden 1, right? So it's like there's a hidden 1 here. In terms of model, it's like there is a hidden 1 here. The constant is like 1 c dot b0, something like that. But in mathematical formula, we typically merge this 1 into this x. So we just omit that. But in terms of Python knowledge, we need this xb. That's going to be defined as numpy c underscore. That's going to give us a constant term. And we're going to introduce this np.ones. Specifically, that's the dimension. And we're going to concatenate it with x. Boom. Okay, so Specifically, this XB looks like this. So we have your original data, that's your X here, and we're concatenated with a bunch of ones. Now we have the setup to find theta. We're gonna call it theta best. And this is essentially a line algorithm, and that's gonna be inverse dot XB transpose dot Y. This dot here means dot product, and this dot here is referring to another function. Basically, whatever code above is doing is going to do a dot product with Y. Don't forget this inverse here. We have this X transpose X, so let's do that. So here we're gonna say X transpose. So here we're gonna say XB transpose dot product with XB. Boom. Okay, so the theta best is gonna be two numbers, 2.26 and 2.86. And they are here to mimic this 2 and 3. So let's run this again, see if this number changes, right? So it kept changing. I think this algorithm should not be able to change the results. I just think when you generate these random number, it's randomly generated so that your data is actually changing. So if you try many, many times, then eventually the average results should be about 2 and 3 for this theta. For the theta 1 and theta 2, respectively. It could occasionally hit a certain data created by this rand here and this rand here that perhaps the data is tipped to the other end of the scale that is not completely random, that you're gonna meet a pair of theta that's not that good. And with this theta best found, we can talk about making some predictions. Essentially, we can grab x new and let's make an NP array. And we're gonna give some numbers, say 0 and 2, okay? And x new b, and that's gonna be NP, C means concat, NP1s with 2 by 1. And we're gonna concat x new. Boom. What's the bug? Data type not understood. NP1s. I forgot to add this as a tuple. That should work. Okay, so now with that being said, y predict, that should be x new b dot product with x, with theta best. And you print out the y predict, that should give you 2 and 8, right? So essentially, if we plug this back into this model, so here, this x has two numbers, 0 and 2. If this is 0, then we have essentially just a 2 here. So this 2 makes sense, this first value. The second value is 8. Let's check that out. Here we have theta 2 is 3. So 3 by 2 is 6. 6 plus theta 1, 2 is about 8. So essentially, these two estimates are very close to what we're expecting theoretically. So that's definitely good. And just to double check this, we can use some fancy library in Python. So from scikit-learn, we're gonna call linear model, import linear regression. Boom. And we're gonna do a linear regression, and that's gonna be linear regression. So we nicknamed it, and we're gonna fit it. So line reg fit xy, and the job is done. Now we're gonna check out line reg. Here we have intercept, okay, and we also want line reg, okay, coefficient. Boom. So we have 2.01, 0.66756, which is very close to the first parameter. And the second one is 3.0347, which is actually very close to this parameter. So there you go. Those are some extra confirmation that we can have to ensure that these matrix algebra here that we just did from scratch works. Just last but not least, why don't we use these parameters on our x new? So we can say line reg predict x new, and that's going to be 2 and 8. So it worked. Specifically 2.01, 066, 8.08, 01579. Okay, so two numbers are essentially completely identical, which is pretty good. So there you go. If you like the channel, give it a like and hit that subscribe button, and I'll see you in the next episode.